video summarizes our approach to the Wessex Water Data Hackathon, which was focused on looking at customer surveys from about 20,000 properties, where they'd gathered a whole raft of information about potential water savings and how they'd implemented solutions at those particular locations. They also provided about 1,200 customer data sets with biannual data reads on meter flow data, and there was about 60 or 70 data sets on daily consumption, so very limited on daily consumption. So what they were looking to do on the hackathon was to get good insights into what they can do to improve these surveys, to get more data out of these surveys, and how to focus these surveys better if they're looking to apply to deliver this at many more customers in the next AMP period. So I'm just going to give you a quick overview of the solution that we applied, and that hopefully will take 4 or 5 minutes. We're then going to create a couple of extra videos after this, actually showing you how we've used MAP to deliver that and to deliver it very quickly and to do all the analytics that we're going to show you that have been done. So moving straight on, our approach was basically to look at applying the 2011 census data to the consumption data and to the customer data. So effectively we are fusing together the census data, which has got lots and lots of parameters, and we focused on a couple of them which we'll briefly cover in the detail later. And then we combined and aggregated all that data from the customers into the wards so that we could do a very brief overview analysis of the key metrics that we had picked out from the data. So effectively these couple of, if you can see this data, we've got detached, married couples, one person, private rented, and these are all the data sets from the 2011 census, and then the average water saved and the average meter flow data. This is the data that we used from the consumption data for each customer. So that's an aggregate value from the customer data that we've brought into the ward information. So effectively by aggregating all that data together, we can get all the data into one place so that you can do this sort of stats analysis much easier. Now at the end of the day, we couldn't spend enough time filtering some of the meter flow data, some of this metering data. We've since done a little bit more work on that and we've got some better results. But at the end of the day, this is a concept. It's to show the methodology that we're trying to apply. So what this has enabled us to do is, by bringing all this into one place, is to allow Wessex, or to allow them to focus and being able to say which are the wards that would offer them the best returns if they said, right, we want to focus, for example, on married couples, and married couples are well linked with total economic activity, so the chances are that they may have the higher water consumption. So these metrics might be able to flag up the wards that would generate the highest water consumption if they applied those that did the surveys in those areas. And so that ranks those 10, that's the top 10 wards ranked on that metric. And then we can also change the variables to say, right, we now want to focus on social renting, and maybe to look at and how we can apply and identify customers who would benefit from getting those sort of water savings as a consequence of social demographics. And that would then focus on those as the top 10. So really what we're doing is providing a tool to allow Wessex to chop and to change and to identify the wards that give them the best outcomes in terms of delivering the survey results, and to get the survey to deliver the best outcomes, I should say. Okay, so that's an overview of the data. What we've done in MAP is to briefly show you is this is the hackathon data. We create templates for the data. So we have ward templates, which is the average with all the calculations in there. We have customer templates with a number of calculations that we've set up, and then we have an attractive list lookup template which is set up as well. So once you've got these templates in place, you can then apply all of the individual records to that, and then we've got within here all the customer records for each individual. That's so actually we created 12,000 records, and each of those customer records has the relevant data and meter flow data in it, and we have all the ward data as well. So those are the individual wards. So if I get to take an example of a ward which we can filter on, to go to Staple Grove. So Staple Grove had 205 appointments in it. It's got total water saved is 10,234 litres. That's the values from the survey. And if we go into here, we can see that these are some ideas of the data that we're looking at. So this is the total metered data going back. This actually starts at 2011. So that's the metered data for the whole of that ward. That's the average flow consumption. So this is the daily values where we've got customers in this particular ward that have got access to that data. And what we have done since we actually presented this at the solution, if I go back to the Staple Grove, we can actually see that we've got an analysis end and start time. Now I'm sorry, but that's in ticks, so it's not very easy to see. It actually, this is the start time is the 1st of January 2016, and we've taken it through to the 31st of December 2018. So that's the tick values there, and that's allowing us to filter this total flow meter data, because you can see that there's some question mark. I have some question marks over this bit of data and this data here. So we've actually just filtered that data between those time ranges, and we've got a better set of data, and that leads us to doing better analysis on those values. So that's a quick overview of what we've done. We'll create some videos showing in how we've set this up and the configuration and map in a bit more depth. Many thanks. Bye.